Hi everyone, welcome to the IoT Hero Show, my weekly showcase of thought leadership in the Internet of Things. My name is Tom Raftery, I'm the Global IoT Evangelist for SAP, and now, on with the show. Hey everyone, welcome to the IoT Hero Show. My name is Tom Raftery, I'm Global IoT Evangelist for SAP, and with me on the show today I have Bill Clee. Bill, would you like to introduce yourself?
Of course, thank you very much for inviting me. My name is Bill Clee. I'm the CEO and founder of a company called Asset Mapping.
Excellent. And this is the IoT Hero Show, so asset mapping obviously has something to do with IoT. Bill, you want to tell us what asset mapping does?
Sure. IoT, yes. I mean, we've found out we've become an IoT company. The company started trying to solve an issue at the London 2012 Olympics, and the issue was as simple as when an engineer needs to go and install a piece of equipment, they're ordinarily given a paper drawing, an engineering drawing, and the issue we had at the Olympics was constantly the engineers had the wrong revision information, the wrong revision drawings. And those drawings were then used to populate other systems, such as Excel files, equipment lists. And because people always had the wrong revision, we were having cameras installed in the wrong places, people had the wrong firmware updates on the equipment. So quite simply, we took the information from CAD, things like AutoCAD, which is a digital system, and we populated Google Maps. So whenever the engineers logged on to Google Maps or to Asset Mapping, they could see the latest design, where a piece of equipment could be installed, should be installed. And from that point at the Olympics, we started adding additional functionalities, such as the engineer could add, when it was installed, the serial number, the firmware, and obviously, as the platform evolved, it was connecting to the real-time systems. Now, if you think about that within a city, that's security systems, building management systems, the equipment used to operate and manage large commercial skyscrapers. And what we were trying to solve is...
So just let me clarify, Bill, because you're talking about using Google Maps, and now you're talking about within a skyscraper.
So, okay, good point, sorry. So, interestingly, you have Google Maps, and it shows you around buildings, but 80% of a city is indoors. Now, the information is normally on a piece of paper, on a file room. What we do is we take those floor plans, we put them onto a Google Map. So you can choose floor 1 to floor 20, and then that will load that indoor floor plan. And then it will show the location of the equipment, say an air conditioning unit, in a certain room. You can click on that icon, that device, and then that will show you the real-time data and all the context information, such as when it was installed, the serial number.
And this is what you're selling to your customers. It's not that I can go along and see inside a building. It's your customers can go along and see inside their buildings and see what's where within their building. Correct,
yes. I mean, also some clients choose to make certain information public, such as airports and rail stations, but probably not all of the equipment, such as CCTV cameras. Now, if you think about it, most of the equipment that we talk about, whether it's IoT or whether the legacy equipment, such as air conditioning systems, it already exists. It's just in silos. Yeah. And for us, where this is evolved, is IoT is an enabling technology to help the engineers, the building owners, do something that they couldn't do before.
Right.
And that's just combining all of these separate silos together.
So in one screen, they can see everything from their aircon to their photocopiers to their coffee machines to whatever else.
Exactly, to their engineers. So it's all about, and then this means when a device breaks, it changes status. It tells you what the issue might be. so the engineer can come along and fix first time. At the moment, this requires multiple visits. I mean, if you think about a meeting room where it's too warm and you speak to reception and you don't really expect anything to happen, but if you complain enough, they might phone somebody up, they might bring an engineer down, and that's costing huge amounts of money for building owners. If I give you an example, 2% of the cost of running a building in energy is about 2%. Just that it's not that big a number. The maintenance, the physical maintenance of equipment is around about 8%. So these are very big numbers, and all the way through, the savings are helping everybody. They're helping the engineers, they're helping the building owners, it's saving money. And this is, so going back to the IoT piece, this is about not just sensors that you can use to augment these existing systems. It's also about connecting all of the legacy devices, systems. One system might be a payment system, like an asset management tool that tells you this device is no longer in warranty, or there's no longer any spare parts. So rather than trying to fix it, it's possibly cheaper to replace it and get the energy savings that come with that. But unless you have that data, unless you're aware of what's going on, it's pure guesswork. So in our scenario, IoT is about connecting legacy systems, legacy devices, and then using newer IoT sensors to augment.
Sure. So if I'm a building owner or a facilities manager for some place, and I've got, I don't know, 10,000 photocopy machines or air conditioning units or CCTVs, how long is it going to take me to connect them up to asset mapping? I mean, it's what's it going to be, half a day each, or what's that entail? Because it sounds like a lot of work.
It does, and well, first of all, there is no magic software that you can just connect and hey presto, there's your building in 3D. And the movie companies would love for us to believe that there is. Now,
zoom in,
zoom in in 3D and switch the lifts off. That's not quite possible yet. So what we would do is, if I give you a scenario of a fairly large commercial building, we would connect a IoT gateway, very small, secure Linux box, to the main building management panel. So in one of these large buildings, in the basement, there's a panel, and we connect into that box, and then we get access to all the live data about all of the air conditioning systems. It could also perhaps be the lift systems, depending on the sophistication of the existing platform. And then what we do is we take the CAD files, again, if they exist, and import that data, and then that shows us the location of all of the devices. So let's say air handling unit number 1, we go into the building management system and find that live data and connect them both together. And then we could go into something like a SAP and say, right, show me the device, show me when it's purchased, and again, combine all that data. So if you start off with decent information, we can do a 5-store building in about 4 or 5 days. Okay. If we walk into buildings that have nothing, what we tend to do with building owners is add that into their maintenance and service regime. So every time an engineer comes to site to service something, they add a bit more data.
Gotcha.
So within a year or two, you should have a digital representation of that building.
Right.
So, and then once you have that data, you can start adding more devices, more systems, finding new context. So the process itself is fairly quick. If you don't do it at all and you rely on paper, you're still responding to problems. 86% of maintenance is reactive. And engineers are spending 65% of their time looking for data. So they're doing this job anyway.
Yeah.
So that's the time to capture the data.
Yeah, no, it's interesting because I remember talking to a guy from a company that was rolling out parking meters, smart parking meters, essentially a smart parking meter solution for cities. And they don't just do smart parking meters and that kind of thing, but what it is he said that's the easy one. That's the low-hanging fruit for a city because you roll out the sensors on the gateways, and that's a revenue generator for the city. So it's an easy sell. And then once you have the gateways in place, you start adding other sensors for air quality, noise, and they still use the same gateways. So it's a much lesser, it's a far easier sell once the initial infrastructure is in place. And it kind of sounds like that's what you're saying with asset mapping. You put in the gateways, and you start adding the easy stuff, and then over time you start adding other services to it, or the building managers can.
No, that's right. And I think if you look at this ecosystem of different companies within our space, smart buildings, smart cities, IoT, we're also working with lighting companies. So they're going in, adding the LEDs, they're adding some sensors, and we're almost following up and adding that new service, such as connecting to the air conditioning systems. And if we go into the building first, those companies can come in because there's now a digital fabric of the building. So
I remember reading or hearing years ago there was a kind of a term that did the rounds. I don't know if it's still doing so, the sick building syndrome. And it strikes me that the kind of things that you're doing should help a lot with that.
And I think the thing is very low cost sensors now, such as CO2, and you can buy them for $40 off the internet, will automatically let you know when the CO2 level goes above 600. You start to get quite sleepy around 900. Right. So we've gone into buildings that have nothing, no systems at all, and just added temperature, humidity, CO2, and noise. And have a fairly good understanding of the building. If you imagine that's a retail store, you would want to know, are people spending more because the air quality is better? Where we're talking about commercial buildings, if a meeting room's slightly too warm, is it going to slow the company down? But if it's a coffee shop and the coffee machine no longer works, or the automatic doors don't open, that can stop them trading. So in some ways, there's more value in the smaller the smaller SMEs understanding what's going on than the large commercial owners.
Right. Yeah.
And there's still a little bit of resistance in the market because we all like to use what we know. It's the market's run via Excel spreadsheets and mobile phones. So it's really trying to find the organizations that recognize the problem in both energy, sustainability, the workplace, efficiency, and work with those to evidence the alternative to what's currently being used. And what this is showing is there's no downside. Everybody wins.
Yeah. Fair point. When you bring me on to an interesting question, though, I guess. You talk about SMEs. Who is asset mapping's customer base? Is it SMEs? Is it large? If I own a fleet of buildings across multiple countries, can asset mapping handle that, or do I need multiple instances of it?
No, very much so. So, our preferred client tends to have buildings over 3 floors because they would ordinarily need a BMS, and it's a quick way to connect that data and pull it out. And they tend to have more than 3 buildings. So that could be all around the world. Now, if you have a single building of 3 floors, you probably have a facilities manager that these people are very competent, they know what they're doing, and don't need a piece of software. Right. But for a large company that has multiple buildings around the world, that's our sweet spot. That being said, we're working with some very large organizations that deal with lots of what we would call dumb buildings, like retail stores and small branches. And there we could use the IoT sensor to pull data out. Now, Later on, we will look at a more consumer market, but I think that's probably 2 or 3, 4 years away. And again, that goes into when we all agree that there's an API or a few APIs we can communicate with.
Sure. I guess the other thing then for any discussion around IoT is the whole security issues. Is that something you're coming across and having to deal with?
Very much so. So we've being a British company, finds the British building owners have to be very mindful of what they connect into the buildings. We are quite risk averse as a nation. So one of the first barriers to us using the system was security. So we worked very closely with Intel. They have a product called Moon Island that's encrypting the data when we connect to the BMS system. That encrypts it on the silicon, so it's got a unique fingerprint, and pushes that to our servers.
Right.
So there's no way to get into that data stream at that point. The other thing we don't do, of course we could, but we've removed the code, is we don't control the systems. We would notify an engineer or a building owner there's an issue, and then allow them to action that themselves. So you have the security around the gateways, which is being solved. It's a slightly higher cost. And then the other issue now is sensors. Do you actually trust the data coming from that sensor? Mm-hmm. So we're working on a project with Cisco and Johnson Controls on exactly that. So we're onboarding these sensors, that data stream can be trusted. So if you think about, again, a data center, and suddenly one of these temperature sensors tells you the room's becoming much cooler, so you try to heat it up, and that, in actual fact, the sensor's giving you bogus information,
right,
that could start having very negative effects on the performance of the building. So it's also trusting the sensors, and there is work being done on this subject. Again, Cisco are doing some things. Other companies are creating what's called PUF, physical and clonable function. Again, the silicon has a unique fingerprint, so the data coming from that device is unique. But these aren't your low-cost domestic sensors you would be looking for on Amazon. These tend to be commercial use, but it's whether the price justifies itself. Now, interestingly, this is where IoT on that point is quite interesting. A typical device at the moment in commercial buildings is normally 15. The cost of the device, let's call it £30. The integration piece is normally 15 times the cost of the device.
Right.
Now, what IoT is going to present is it might be a slightly more expensive piece of equipment, but the integration almost becomes immediate. Open APIs. The device can say, "Hey, I'm a temperature sensor. Here's my location. Here's my data," and it means the whole integration scenario becomes a infinite plug and play.
But are we there yet with the standards around these things?
No. I think we're playing with scenarios of this at the moment using an API or a specification called HyperCat that we're testing some of these scenarios. It's not whether the technology exists or whether the specifications exist. It's whether everybody else is going to embrace them. Now, HyperCat is a fantastic specification, but it's from a government in the UK, which is a small island off Europe. Will that be adopted by other leading players? And I think it doesn't really matter whether it does or not, because whether it's a UK specification or an OIC, an IIC, it doesn't matter, as long as we can all communicate with these devices together or via one or multiple IoT platforms. Yeah. But it's going in the right direction, I think, more from the industrial side.
Okay, and of course, industry is where it's all happening right now.
I think it's the only place it can happen. I mean, There's, what was the saying I heard recently, and it's one that everybody uses, is APIs are like toothbrushes. Everybody has one and doesn't want to use anybody else's. And I think in the connected homes, there's just way too many APIs. And I think the industrial, I don't know, there's probably about 150, 200 that I'm aware of within the existing legacy equipment.
Yeah, I think in the home environment anyway, the cost issue is an issue. As in, it's 10x your typical device. It's normally around 10x. So your Philips light bulb is normally 10 times the cost of a regular LED light bulb. Your Ring doorknob is usually 10 times the cost of whatever. Everything is 10x more, and you're not getting cost savings as a consequence of buying them. You're getting a little bit of you can access your light on your phone, that kind of thing. Big deal. There's no huge cost saving associated with it. So I think the home environment, it's going to take a while yet, just even on the cost basis. Whereas in industry, the kind of things you're talking about, reducing costs of maintenance, making things more efficient, you can see straight away the benefits there.
Absolutely. I mean, I think from a small company out of London, I mean, we've had to prove security. We've had to prove that this is a return on investment within a year, that it allows us to integrate with legacy equipment, but also provide an open platform that can work with future devices. But it all comes back down to helping the engineer, which is why we started the company, saving money for the financial director. So it's the easier technical play, but it's still an industry that traditionally doesn't enjoy change. But I think that's going to be very much like the and I dare I say it, but the whole Uber model of, we used to have taxi drivers. We used to have these places in basements where we used to go along after a couple of beers and people smoking cigars, and you might get home. And not saying that these people are the same, but we have the engineers, and that entire process of speaking to somebody in reception who speaks to an FM, a facilities manager, who eventually sends out somebody to fix it, that's all going to be automated. Yeah. And that's where the real change in the way we manage buildings and cities and devices is really going to have a big impact on society. I mean, these are huge numbers. I mean, the energy consumption of buildings, the amount of people that work in construction and maintenance, and we're using technologies that are 20, 30 years old. Yeah. And it's such a big challenge because you almost have to be a very large player to tackle it, and they tend to go down the vendor proprietary systems. But that's changing with IoT. IoT is allowing anybody to come along and play.
True. And just to that, you mentioned that your typical customer was someone who owned a building with more than 3 stories and 3 buildings, and from there up. Do they break out into any particular sector, government, commercial, some large property holders? Is there any buckets they fall in typically?
Yeah, I mean, we tend to work, or the easier, or the most traction we've had is from commercial building owners or commercial property managers. Okay. So organizations like CBRE, JLL, who manage large properties around the world, have very little insight to what's going on, for example. Then you've got the larger building owners. And what's very interesting about these companies is because they outsource all of their service work to facilities management companies, to service companies, they have no insight what's going on in their building. So every 5 years when they change maintenance company, they don't know what they have. Yeah. They don't know when it was last serviced, how many bits of equipment.
Right.
So these are the people that actually really have the big issue.
Yeah.
So they almost need to become custodians of their own data, or they need to understand what's going on. And then it's not just about quicker maintenance. They can then start looking at lower cost insurance,
Yes. Yeah.
quicker payouts on some of these
And
policies.
can they expose the data to the insurance companies?
That's what early conversations are exploring. I mean, it's almost the black box in a car. If you're 17, you put a black box in, you drive well, you get a cheaper policy. And why shouldn't that be the same in large commercial buildings? If you've got two exact buildings, one's well maintained, the energy consumption and all of the information that comes with IoT should give you a better policy, should give you a lower cost. Now, I don't think this is something that insurance companies will push, but I think they would welcome the data.
It probably depends on the type of data as well, because insurance companies typically, they don't care about the energy efficiency of a building, but if they can see things like flood sensors and fire sensors,
Exactly.
then those are the two things they care most about: flood damage and fire damage.
Well, I mean, I read, and again, don't quote me on this exact number, but I was reading an article about it a year ago, and about 20% of all commercial building claims are water damage, whether that's leaks, whether that's pipes bursting, also whether rivers flow through their offices. And these are huge numbers. I think in the UK alone, it's about 1.1 trillion. So 20% of that number. Actually, and I think that's also domestic homes as well. So
right, but still, it's
again,
hundreds of billions.
Yeah. So adding these sensors, so as soon as there's a leak, it can be dealt with rather than waiting for it to drip through 2 or 3 apartment buildings, floors, or commercial offices. So and that's just one of the potential benefits of sensoring buildings. Yeah. But the short term of doing it still has a return on investment within a year. So there really is very little reason to not go down understanding what's going on within your commercial space. Whether that's energy efficiency, whether that's maintenance, or whether that's the well-being of your employees or your tenants. So, and I think that there just hasn't been this awareness. That there's systems that people purchase, without naming any big companies, aren't really designed to share the information over the internet. And if they do, it's to another very well-trained engineer that might be able to tell you what certain graphs mean. It's not being done in the same usability of what we come to expect from domestic devices such as Nest.
Right.
So, but that's where the opportunity is right now for companies like ours and other. I think the term is prop tech companies. So
not an expression, right, or a phrase that come across before. Prop tech. It makes sense. Property technology. Okay.
Yeah, exactly. It's prop tech, IoT, smart cities, smart buildings. It's very much the same thing. It's all about data converging.
Sure. Bill, we're coming towards the end of the show. Is there any aspects of IoT and asset mapping that we haven't touched on that you think would be good to highlight?
I think I've probably covered most of it. I think the one thing that's really changing for us is you almost have a new generation of engineers who are expecting more. They're using technology to solve some of these issues.
Great.
And I think the one thing is, this isn't really about technology. It's about the use of technology to do something different. And it's this new generation that's really driving this, who aren't accepting the old ways of doing things. It's a traditional way that's been the blocker.
Yeah. Great.
But good.
Super. Bill, if people want to find asset mapping and yourself online, where are they best to go to?
Google Asset Mapping. The company is called Asset Mapping, assetmapping.com. And yeah, you can find me, Bill Clee. So my email is bill@assetmapping.com.
Super. Bill, that's been great. Thanks a million for coming on the show.
Absolute pleasure. Thank you very much. Thanks for the invite.